Okay, question number 11. Consider the curve C defined by the equation like this, shown in the following diagram. The curve has a line of symmetry y equal x. So it means the line of symmetry on y equal x is this curve is a self-inversive. Inverse of this curve is itself. There are 2 points on the curve where the tangent is horizontal. These points are labeled P and Q. So as you see, P as over P, the tangent is horizontal, and the Q also tangent is horizontal, which means slope is 0. Show that the dy dx is like this. Number 8 is 5 point. So we need to find dy dx of this function, right? So we can do differentiate left and right hand side with respect to x. Will give us this differentiate to the e to the fx is itself e to the x plus y, and f prime x, which is x plus y differentiate. So it's going to be 1 plus dy over dx. Okay, equal differentiating x squared is 2x plus differentiating y squared is, we have to apply the chain rule, which is 2y differentiate with respect to y first, and times dy over dx. So you can see there's a term and dy dx over here and there, and then moving dy dx to the right, to the left hand side will give us e to the x plus y minus 2y everything of dy over dx. Moving rest part to the right hand side will give us 2x minus e to the x plus y. So therefore the dy over dx that we want to get should be expressed as 2x minus e to the x plus y divided by e to the x plus y minus 2y. Yeah, it's exactly the same. Okay, B. Show that the x coordinates of the point P and Q satisfy the equation of this. So x coordinate P and Q is the position where the tangent is horizontal, which means that dy dx in this expression over here, this one becomes 0, right? So we put this one equals 0. We have to solve the equation. So we have to solve the equation, right? So we have to solve 2 equations. So first one is 2x equal e to the x plus y. So we have to follow the point should satisfy this condition first. Second condition is equation should be on this curve. So e to the x plus y equals x squared plus y squared. So second condition is e to the x plus y equals x squared plus y squared. So out of these two conditions, we have to get the expression like this expression. So let's see that how. We have to eliminate x to see the equation of, we have to eliminate y to see the equation of x. How do we get elimination of y? So as you see, already e to the x plus y is here, is this 2 is equal, this 2 is equal, which means that this 2 is also equal. See? So we can just put over here equal x squared plus y squared. And then all we have to do is eliminate just y. How? So we can put the ln on both sides of this equation. So that means x plus y equals ln of x squared plus y squared. No, it's not gonna work. It's not gonna work. So this time we have the x plus y over here. So ln go down. So we just apply ln on both sides this equation. So it's gonna be ln of 2x equals x plus y. Yeah, got it. So it's gonna be y equals x minus ln of 2x. So putting y over here, we will get the equation required. Yeah. So putting y over there, it's gonna be 2x equal x squared plus y squared. Y squared is this one squared. Y squared is this one squared, right? So this one squared is gonna be x squared minus 2 times ln 2x x, right? 2ab minus 2 times ln 2x x plus ln 2x everything, ln 2x everything squared. So it's gonna be 2x squared yeah, plus ln 2x squared. Yeah, plus ln 2x everything squared minus 2x ln of 2x minus 2x. Yeah, minus 2x equals 0. It's the same as the requirement. So this and same. Okay. Hence to find coordinate P and coordinates of Q. So P and Q satisfies this equation, so we need to use calculator. Okay, so go to calculator, close everything we don't need it, second quit and clear everything and make some space. Okay, we need to put to get the x value of this one, we need to use a graph function. So we use y2, 2x squared plus open parenthesis ln of 2x close parenthesis twice and everything squared minus 2x of ln 2x close parenthesis one time negative 2x equals 0. We need to find 0 of this function. So let's see. So trace first 0 is x is 0.331. So p coordinate will be 0. X equals 0 of 331 comma y value, right? And then cube point will be x equals 1.84 comma some y value. So we need to find y value of PQ when x equals like this. So y value of this one. How can I put y value directly over here? Or we can put y value over that equation. Yeah, when x equals 0 point how much? 0 point of 331. So let's say second quit 0.331. Let's store it of p value, p of x value, right? And 0 point of how much? 0 0.1. Sorry, not 0. I'll do 1.84. Let's store it to of q value. This is x coordinate of p and q. Go to here and delete this one, and then see. So e to the x plus y when x equal p. So e to the p plus y equals x equals, and it goes to the left hand side, minus x squared. So minus p squared minus y squared is going to be x squared. So we need to find out 0 of this value, right? So see, come on, let me show you. Show me 0. Show me 0. Why it's not open responding? Yeah, here, minus 0.743. Minus 0.743. So second function is when p, yeah, and p just changed to q. So this alpha q, delete. P just changed alpha q, delete. So we need to find 0 of this function. 0.538, negative 0.583. Yeah, P and Q. Using the line of symmetry, write down the coordinate of points on the curve C where the tangent is vertical. So when tangent is vertical, using line of symmetry, that goes over this point and that point. Because this point and that point is follow the symmetrical line of this one, P goes to that point, Q goes to that point. So this 2 point is line of symmetry is y equal x. So just switching coordinate of x and y, right? So so P prime, let's say P prime is gonna be switching x and y is gonna be 0.743 comma 0.331, and then Q prime where tangent is vertical is gonna be switching x and y coordinates is negative 0.583 comma 1.84. Okay. D. Find the coordinate of the point where on the curve where the tangent has a gradient of negative 1. So where the tangent has the gradient of negative 1. Negative 1 line goes like this, where tangent meets this line. So as you see, you can find each point over here. This is negative 1 slope and meets over here. Because y equals negative x is reciprocal to vertical, not, what do you say? Is making 90-degree angle of y equal x. This is y equal negative 1. This this line is equation of normal to the equation of normal to the curve where intersect with 90-degree angle. So equation of tangent where intersect is negative 1 is right over here. So this point here is the where this curve here meets the y equals x. So we can solve like this. So y equal x. So y equal x intersect this curve. So we can solve these two equations, putting x on the y. So it's going to be e to the x plus x equal x squared plus x squared. Yeah? And then e to the ex, 2 times x equals 2x squared. So go to graph of here, and then e to the 2x, putting 2x squared to the left hand side, minus 2x squared. Find the zero of this graph. X equals minus 4, 5, x equals minus 4, 5, 1. So x equals minus 4, no, not minus 4. X equals negative 0.451. So y should also the same. So minus 0.451. So the coordinate is minus 0.451, comma, minus 0.451. Yeah, that should be the answer.